Hello everyone. I haven't posted anything for a while because I've been pretty busy, but I'm really grateful to everyone that has watched, liked and commented on my videos. I've decided to do a pygame tutorial series that creates a game from scratch. The game will feature basic city building aspects and an isometric perspective, and I really hope you enjoy this first part. So, starting from a completely fresh project, we're going to the first thing we're going to create is the entry point for our game. And we're going to call this main.py. So this is the file that will be run externally to run our game. It's quite nice to keep this separate from the rest of the game scripts, especially when we turn this game into an executable. Right now, this script will contain mostly comments, kind of serving as placeholders. Because we haven't actually written any code yet. So first thing we can do is import pygame as pg. Then we're going to define our main function. So we're just having a couple of placeholders here, running and playing. So this is a distinction between when the program is running, for example like menus, and when the game is actually playing, when that's playing. Initialize pygame. Can initialize the music mixer. We're going to create a screen, and in this game I'm going to make the screen full screen. Also our clock object to control the frame rate. Eventually we will be programming menus, and I normally write them as classes, so I'm just going to remind myself that I need to initialize a menu class here, initialize my game class here, and then we're going to get into the main loop. So while this program is running, start menu goes here, and then while we're playing, the game loop here. Okay, and that's all of the placeholders that I need right now. I'm just going to finish this off by because this script will be run externally. We're just going to have if name equals main, then just run the main function, and that's all we need to do for now. The second thing I'm going to do is to set up some of the folders we'll be working with. The first folder we're going to be working with is our game folder, and this is going to contain all of the scripts for that kind of define and control our game. So now that we have our game folder, we can start constructing our game. The first thing we're going to create is the actual game class. So I'm going to call this game.py. Again, we're going to import pygame as pg. We're also going to import sys, and then we can start defining our game class. So class game, going to define the init method itself. We're going to feed it the screen and the clock that were defined inside of main. Going to start saving these inside of the game class. And I normally calculate the width and the height, because we'll probably be using them multiple times throughout the game, so it's good to save them as separate entities. So get size. Beyond that, I'm going to define a run function, so that will be the method that's exposed in the main loop. And here we can say self.playing equals true, while self.playing, first we're going to control the frame rate, so we're going to do clock.tick, and that's 60, so that's 60 frames a second. We're going to have a call to any events. We're going to have a call to update, so this is where we're going to update the game, and then finally we're going to draw. creating our events method. In here we're basically just going to have the kind of logic for us being able to exit the game. So for event in pg.event.get, if the event type is pg.quit, so that's if we actually close the program, we're going to go pygame.quit as well as sys.exit. I'm not sure if this actually is helpful when the game is full screen, but I normally put it in there. The other way for us to exit the game will be pressing the escape key. So I'm also going to type that in. So if event.type equals pg.keydown, and if this event.key equals the escape key, then we're going to do exactly the same thing. So pygame.quit and sys.exit, and that should give us a clean exit from the program. So the next method that we've mentioned is the update. Right now we have nothing to update, so I'm just going to put in more of a placeholder method here and just pass. And then finally we're going to have our draw method. Again, nothing to draw, but I'm going to just fill the screen with a colour. So let's have a black background. And then finally we need to flip the display, which will make sure that it updates. We now have a very, very simple game. So going back to our main script, we need to import the game class. So from game.game, because it's inside the game folder, import game. And here under our placeholder we can do game equals game dot screen and clock, and here we want to run the game, and we're going to put game.run here. So now let's see if this works. Okay, and we get a black screen, which is actually all our game is right now, so that's worked nicely. And then pressing the escape key, we managed to exit. The next thing for us to do is to create our world, where we can start creating this city building game. And as explained in the introduction, it's going to be from an isometric perspective. So our task right now is to create this kind of isometric grid for us to start programming our game. So inside the game folder, I'm going to create another script called world, and in this script we are going to write our world class, which will handle all of the tile creation and the tile properties that we want. So importing pygame, creating this class called world. Inside the init method, we want to pass it 4 parameters. The first 2 parameters are going to basically define the size of our world. So we're going to call these 2 things grid length x and grid length y. Basically, so this will kind of define how many kind of rows and columns our grid will have. So if we're saying 10 grid length x and 10 grid length y, it's going to be a 10 by 10 kind of matrix. The next 2 parameters are going to be the width and the height, and that's of the screen. So first I'm going to save all of these things inside of the class. So that's grid length y, x, grid length y, and also the width and the height. The next thing for us to do is to start by creating our world grid, and this initially is going to be a grid of squares. So I'm going to write a method called createWorld, and inside this method I'm going to begin by initializing an empty list for our world, and I'm going to start iterating over different x values up to the grid length x, and then different y values up to the grid length y. So for grid x in the range self.gridLength x, for each of these elements we're going to append a new list, and so that will give us this kind of grid of values where it has an x and a y position. Then we're going to start iterating through the y values. And for each of these x or y values, I want to initially create a square. So for this, I'm going to create a new method called grid to world. And this method will transform our grid coordinates into the different tile elements of our grid. So in here I'm going to have two parameters, the grid x, the grid y, and we're going to define a rectangle, or in this case a square, and the square will have the four vertices of this grid element. So the first vertex, being the kind of the left-hand corner, is going to be grid x, and now we need to define like the size of the tile. And I'm going to create a new script called settings.py where I can save different constants, and I'm going to make the tile size of this game 64 pixels. So here we're going to do the x position of the grid multiplied by the tile size, and I just need to import that. So from .settings import tile size, and then for the y position it's going to be the same thing but with the grid y. Now I'm just going to write in the other three vertices of this square. Okay, finally I can return, actually I'm just going to create a kind of dictionary, because we're going to add more output to this later on. And in this dictionary I'm going to store the grid x and the grid y. So basically, this dictionary is going to hold all of the different kind of properties and information we want to keep for this specific tile or element in the grid. We're also going to store the Cartesian rectangle, keeping it as rect, and finally we can return out. So back in our nested loops, we can create this world tile. So world tile equals grid, actually self dot grid to world, and we're going to pass it the grid x and the grid y. Now that we have this world tile, that's very basic right now. It just has the grid coordinates and also this square. We're going to append this into our world. So this is going to be the position of grid x and append here. Finally, we can return this world object from create world. Now that we have this method for creating our world, we're going to use it inside our init function. So self.world equals self.create world. Okay, now we can create a world. We're going to jump back to our game script, and we're going to use it here. So from .world import world, I'm going to initialize it here. So self.world equals world, and we are going to give it 10 grid length x, 10 grid length y. Also going to import the tile size, and here will be the self.width and self.height, which we'll use later on. Now that we have our world in our game class, we can start drawing these squares. So we have a very simple basis which we can build on. So we are going to start iterating over the grid values again. So grid length x, y in range, self.world dot grid length y. And first we're going to extract the square, so I can call this SQ. And inside self.world we have this object called world, and we can extract the square using the elements x and y, or positions x and y, and we called it inside our dictionary the cart rect. We're now going to turn this square into a pygame rectangle, so we're going to define this as rect equals pygame rect. We can define a rectangle in pygame using the left-hand vertex and then giving it a width and a height. So first we're going to put in the first element of our square, because that was the left-hand vertex. So square like so, and then we can use the tile size for our width and height. Now that we have a rectangle, we can blit this to the screen. So pygame.draw.rect, going to draw this to self.screen, and we're going to make this blue, drawing the object rectangle and giving it a width of 1. So running our game again, we can see what this looks like. And here in the left we have this this 10 by 10 grid, and we're going to now start using this to first transform it into an isometric perspective, and then we can start drawing stuff on top of it. What we're going to do next is now take this these squares and transform them to have an isometric perspective. So returning to our world script, we are going to continue with this grid to world method, and we're going to transform this square into an isometric perspective. So to do this, we're going to define another function which is just going to turn Cartesian coordinates into isometric coordinates. So I'm going to call this define cart to iso, and we're going to pass an x and a y, and the transformation will look like this. So the x coordinate of the isometric position is equal to x minus y of the Cartesian, and the isometric of the y is equal to x plus y divided by 2. And then we're just going to return these two coordinates, so iso x and iso y. Back here, we're now going to define an iso poly, and by iterating through the x and y values of this rectangle, we're going to create our isometric polygon. So self.cart to iso x and y for x, y in rect. And we're going to add this into our return dictionary, so I'm going to call this isopoly. We can verify that this has worked correctly by returning to game. So similar to the square, but this time we're going to extract the polygon from the dictionary. So returning to self.world.world, the x and the y, but this time extracting the iso poly. And we can simply draw this to the screen using pygame.draw.polygon, self.screen, and we're going to draw this as a red polygon, and again using a width of 1. So running this, we can see that it's worked, and we can see half of it. So we need to do a little bit of correction. Going back to the game, we can basically offset this polygon so that we can see all of it on the screen. So we're going to iterate through the list, and we're going to do x plus self dot width over 2, so the center will be in the middle, and similar thing to the y, but it's going to be self dot height over 4 for x, y in P. Now running the script again, and we get the this nice kind of isometric grid in the center of our screen. That was it for part 1. In the next part, I will show you how to render images to the isometric grid we just created. I will cover how we can draw some tiles as a batch for efficiency, and other tiles iteratively so that we maintain the correct render ordering. Alright, see you in the next part.